triangles.
In this chapter, circles, we discussed about the tangents. Here the chapter title is triangles, but here we discuss about the similar triangles. Similar triangles. Okay. We have studied a lot about triangles, but here in this lesson, we'll discuss what is similar triangles, the idea, the concept, and some of the theorem related to similar triangles. That's what is sixth chapter, triangles. Okay. In the textbook, first page, one picture is given. What's the height of mountain, or what's the distance from moon to earth? Or what's the radius of earth? And such questions, how we can find out? We don't measure using tap, but we using the idea of these similar triangles, we can find out these all. The height of a mountain, the distance from earth to moons or sun or some other galaxies between stars and etc. Okay. So the large distances we can calculate using the idea of similar triangles, and also some ideas in the chapter number 8, the trigonometry. The similarity, the concept is very simple. If two figures have same shape and different size, they are similar. We can say they are similar. All circles are similar. All circles are similar because their shape are same, but size can be different. Circles are always similar shape. Okay. And the squares have same shape, but size can be different. So all squares are similar. We can say all squares are similar. Okay. Equilateral triangles. Equilateral triangle is a special kind of triangle. We can say all equilateral triangles are similar. So here all circles are similar, all squares are similar, all equilateral triangles are similar, but the quadrilaterals, all quadrilaterals are similar. That is a wrong statement because their shape may be different. I will show you a quadrilateral next picture. Look here, this is a rectangle. Rectangle is also a quadrilateral. Okay, so these three are similar rectangles. These three are similar rectangles. Okay, because length is to breadth is same in all these three. Length is to breadth is same in these all three shapes. What will happen if we stretch the width or the height? Will we get a similar picture?
No, sir.
No, right? So what happens? So suppose the first picture, suppose I stretch like this. So the picture will look like different. We cannot get a similar picture. Think about your picture. Suppose you have a picture, a square picture, a photo of you in the size 1:1. Okay, suppose the length and breadth are equal. A square picture. If you stretch the sides like this, so you will become fat. Okay, so they are not similar. So rectangles in general, they need not be similar. Okay, in some conditions they are similar. When they are similar, if the length is to breadth is same, if the length is to breadth is same, then the rectangles are similar. Otherwise, they are not similar. So we cannot say all rectangles are similar. We cannot say. But for some of the shapes, we can say all shapes are similar, like all circles are similar, all equilateral triangles are similar, and one more we discussed before, all squares are similar. Suppose this picture, if stretch like this, okay, so we will get some different picture. The shape has been changed. They don't look similar. Therefore, they are not similar. They will be similar. We can change the size without any change in the shape, only when if we change the size by equal ratio between length is to breadth. Okay, so if the length is to breadth is same, so we will get a similar picture. In that case, they will be similar. Therefore, we cannot say all rectangles are similar, but under some conditions they are similar. Okay, same idea will happen about the triangles. That's what our focus. No, all squares are similar. All squares, because the ratio is always 1:1, right? All squares, the length is to breadth is always 1:1. So all squares are similar. All circles are similar.
Now what about other quadrilaterals other than squares and rectangles? So you can see two quadrilaterals here, namely ABCD and PQRS. Their angles are equal and they look same shape. So these two are some example for similar quadrilaterals. Here you can see their sides keep same ratio. So look here, if you observe the sides of these two quadrilaterals, you can see that the sides of quadrilateral ABCD are doubled, multiplied by 2 to get the sides of quadrilateral PQRS, right? You look here, AB is 1.5 and PQ is 3, just doubled. Same for the other sides, just doubled. So we can see in any quadrilaterals they are similar. You can see two conditions. One is their angles must be equal and the sides must be in the same ratio. Okay, or in other words, you can see the scale factor is same. Here in this case the scale factor is 2. The sides are taken just double. So we can say that these two quadrilaterals are similar. Now what about these two? Are these two quadrilaterals similar? So you check whether the angles are equal and sides are in the same ratio or not. So look here, the sides are just doubled, right? So the scale factor is same, or the sides are in the same ratio, we can say. But what about the angles? Their angles are not equal, right? So we can say that these two quadrilaterals are not similar. And this condition we have just discussed, we can generalize for other polygons. So polygons of higher number of sides, maybe 5 or 6 or 7. So these are the two conditions you want to check, whether all the corresponding angles are equal or not, and whether all the corresponding sides are in the same ratio or not. If these two conditions are satisfied, you can say that the given two polygons are similar, otherwise not. One question, very simple question. Exercise 6.1, first question. Fill in the blanks using the correct word given in the bracket. First sub-question, all circles are dash, congruent or similar. What will be the correct option? Similar, right? For two circles to be congruent, their size must be equal, but that is not necessary for similarity. So here the correct option is similar. We can say all circles are similar in shape. And second one, all squares are dash, similar or congruent. So the correct option will be similar by the same reason as in the first sub-question. And third sub-question, all dash triangles are similar, isosceles or equilateral. So the correct option will be equilateral, right? For equilateral triangles, their shape will be same and their sides are in the same ratio, always 1:1:1. So all equilateral triangles are similar. And last sub-question, two polygons of the same number of sides are similar if A sub-question their corresponding angles are dash and B sub-question their corresponding sides are dash. Equal or proportional you want to choose. So what will be the correct options? In the first sub-question A, the correct option will be equal, and in the second B, the correct option will be proportional, right? We already discussed this one. So what we studied now? First point, two figures having the same shape but not necessarily the same size are called similar figures. And second point, all the congruent figures are similar but the converse is not true. If two triangles are similar, we cannot say they are congruent. But if two triangle or two polygon, any number of sides, if they are congruent, they must be similar. And third point, two polygons of the same number of sides are similar if first condition their corresponding angles are equal, and second condition their corresponding sides are in the same ratio. That is, the sides are in proportion. So that's the end of this video. In the next video, we will concentrate on triangles, as the chapter title, triangles. So we will discuss more properties and some theorems about the similarity of triangles. Okay, see you next time. Bye.